In example 5, we're determining whether functions are even, odd, or neither, and these are the rules you need to know. If you plug in a negative into the function, if you get a positive answer out, then it's an even function, and if you get a negative answer out, then it's odd. Now, it's not just positive and negative. It's if you plug in a negative and get the original function back, and it's positive, and if you get the original function but everything has changed signs, then it's odd, and we'll see that in these examples. So I'm going to plug in a negative x into the function and see what happens. So I've plugged a negative x in for x, and when you cube a negative times a negative times a negative is negative, so we can move that negative in front. And so what we see is we have the same function back, only it's negative, so that would be this one. It's odd. Here, if I plug in a negative x, I'm going to have a negative x cubed and a negative x. And so what we see here is we get a negative times a negative times a negative, which is negative 3x cubed. This negative can move in front on the 2. And we've got negative 5. Now, the 3 has changed opposite sign. 2 has changed opposite sign, but 5 hasn't changed at all. So this is neither. Everything has to change if it's going to be odd. And because the 5 didn't change, then it's neither. For C, we can plug in a negative x. So we plug in negative x for the x variable. When you square a negative times a negative is positive. So that negative just goes away. So negative 4 is going to stay the same. And we see we've got negative 4x squared. We've got negative 3. Nothing has changed, so it's even. We plugged in a negative and got the original function back. Nothing had changed. Here we can plug in a negative into the g function. And so we've got a negative x cubed. That's going to stay negative, so put the negative out there with the 5. This negative will stay, so we move it out front. It becomes plus. So 5 has changed opposite signs, and x has changed opposite signs, so this would be an odd function. In example 6, we're looking at a graph and determining whether something is even or odd. It is even if it's symmetric to the y-axis, and it is odd if it's symmetric to the origin. So A is symmetric to the origin. You can kind of think of that as diagonal symmetry. So we see the diagonal quadrants are the same. So that's how you can tell that this is odd and symmetric to the origin. Or the other way to think of it is it's symmetric. Origin means that it was symmetric twice, to the across the y and then down across the x. So if you imagine this, we'll just use this section of the graph to talk about that. So if you imagine that flipping over here and then flipping down here, that's how we know it's origin. It flipped over the y and then it flipped over the x, and that would be symmetric to the origin. So here we see diagonal quadrants look the same, diagonal quadrants look the same. Also, if you were to flip this up and then over, it would match up. If I flip this line down and over, it would match up. So this is symmetric to the origin and is odd. This one, the diagonal quadrants are not the same, but over the y-axis, they're the same. So this matches up with this on the other side of the y-axis. So it has y-axis symmetry and is even. Here, this is symmetric to this side, but then there's this whole extra thing that is not symmetric. So this is neither. And this is symmetric here at this axis of symmetry, which is not the y-axis. So this is neither. It has symmetry, but it's not symmetric at the y. In example 7, we are writing down where are the graphs increasing, decreasing, and constant. A graph is increasing if the y values are rising left to right, decreasing if the y values are going down left to right, and constant if the y values are staying the same from left to right. So let's go through and put all of our increasing sections. So increasing. I see that this graph is increasing from -3 to -2. We're talking about x values here. I also see it's increasing here from 0 to 2. On this graph, the entire thing is increasing. So it's increasing, let's imagine there's arrows here. It's increasing -infinity to infinity the whole time. In this one, we see it's increasing from -1 to 0 and increasing from 1 to 3. Here it is only increasing from +2 to +3. And again, this is where the graph is rising from left to right. Here, from this point to this point, the graph is increasing. So that would be from -π/2 to +π/2. Again, we use x values to describe where on the graph something is happening. And then this one's increasing from -π to 0. Now let's go through and put all the decreasing. So this is where's the graph falling from left to right. This looks like it's falling a little, but it's actually supposed to be constant. If you look at the y values, they have the same y value, so it's not supposed to have looked like that. Here, this is actually falling. It goes from 2 to 0 for your y values. So the x values here are 2 to 3 is where it decreased. And that would be the only spot. This graph didn't decrease at all. This graph is decreasing here from -3 to -1. And it's decreasing again from 0 to 1. This graph, we've got decreasing from -1 to +1. And that would be the only spot. Here we're decreasing twice. Here from -π to -π/2. And here from +π/2 to pi. And this graph is decreasing from the x value 0 to the x value pi. All right, let's look for constants. Where does it stay the same? So here the graph is the same from -2 to 0, so it's constant. From -2 to 0, the y values didn't change. There are no constant sections in this graph. There are no constant sections in this graph. Here we've got a constant section, and here we have a constant section. So let's imagine there's an arrow there. So it's constant from -infinity up to -1 on the x-axis. And then it's constant again from 1 on the x to 2 on the x. There are no constant sections in this graph, and there are no constant sections in this graph. In example 8, we are looking for any local maximums or minimums. In order for it to be a maximum, it must increase and then decrease. In order for it to be a minimum, it must decrease and then increase. So here, this is a top point, but it never increased and then decreased. It has to do both. It has to increase and then decrease to be a maximum. So my only maximum is here at 0, 3, because it increased and then decreased. And then I look for minimums. Minimums have to decrease and then increase. Here I've got a decrease and then increase. So I've got a minimum at this point. And again, decrease and increase, so a minimum at 2, 0. In graph B, we have a minimum at negative pi over 2 because it decreased and then increased. And we have a maximum at pi over 2, 1 because it increased and then decreased. In C, we have no max and mins because there's no decreasing. This graph increased the entire time. It never went back down, so there's no max and there's no min. In example 9, we're kind of just combining all that together. So is the function increasing on the interval negative 8 to 2? Remember, these are x values. So negative 8 to negative 2. Did it rise from negative 8 to negative 2? And it did, so yes. Is the function decreasing from negative 8 to negative 4? So we're looking at x values again. Did the graph go down from negative 8 to negative 4? And that would be no. Is the function increasing from 2 to 10? So we've got from 2 on the x to 10 on the x. And did it increase that whole time? No. Did it increase at all? It did increase from 5 to 10. It increased from 5 to 10, but it didn't increase that whole interval. Is f decreasing on the interval 2 to 5? So from 2 to 5, did it decrease? Yes, it decreased that whole time. And then it wants us to list the maximums and minimums, the local maximums and minimums. So we've got a minimum at negative 8, negative 4. We've got a minimum at 0, 0. We've got a minimum at 5, 0 because they decreased and then increased. Then we look for maximums. This is not a maximum because it didn't increase first. This is a maximum because it increased and then decreased. Maximum because it increased and then decreased. Not a maximum because all it did was increase. It never decreased.